This is the real Tom Rose, and we're going to solve a ratio problem. And this ratio problem has a little twist, which is there are numbers in a sequence. And anytime the test refers to a sequence, they're simply referring to numbers that are in order. In this case, we're dealing with 10 numbers in a sequence, and it helps to number these because we're going to be referring to them by number. Now, they don't actually ever tell you any of the numbers in the sequence, but it helps to imagine real numbers. So why don't we start with simply the number 1 so that we have something to refer to. And they say the ratio of each term to the term preceding it is 3 to 1. So when they say the ratio of a term to the term preceding it, I like to think of a fraction. Term to term preceding. Is 3 to 1. So in this particular case, we've started out with, let's use 1 and 2. Right here. So if 2 is the term, right, term in quotes, then that's the number we don't know. Let's call that x for now. To the term preceding it should be equal to 3 over 1. And you can solve this to show x equals 3. Now what we're hunting for, since we have 10 of these, is a pattern. And if the ratio is 3 to 1 on each term, you can start to see the pattern right away, which is that each term will be 3 times as great as the term that came before it. So we can fill this 3 in now. And as we go forward, each term will need to be 3 bigger than that. And you could keep doing the exercise we did above if you need to. These numbers are going to start to get big pretty quickly. So what you may want to do is actually think of these slightly differently. You may want to think of these as, since you'll notice that we're actually multiplying by 3 every time, these will all be powers of 3. Here's just 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. And all the way up here, notice that this term has a power which is 1 less than its slot. So 4 is 1 less than 5, 3 is 1 less than 4. This is what we mean when we say we're looking for a pattern. That's a pattern. So we can use the pattern to extrapolate what the values will be up here at slot 10. It'll probably be 3 to the 9th. And in the 6th slot, we can anticipate 3 to the 5th. So what's the ratio of the 10th term to the 5th? Well, let's do the 10th to the, oh, they actually asked for 6th. That will be equal to 3 to the 9th over 3 to the 5th. And you can cancel out 3 to the 5th with 3 to the 9th to get 3 to the 4th, which is equal to 81. 81 will be your answer, and that is E. It should also be pointed out that if the clever solution doesn't make itself apparent to you, there is a fallback. The fallback is use your calculator and calculate every value. And I'll show you that this doesn't take that long, actually. So 81 times 3 is 243. Times 3 is 729. Times 3 is 2187. Times 3 is 6561. I'm doing these on my calculator right now. Times 3 is 19,683. And if you want, you could simply do 19,683 divided by 243. If I plug that in my calculator, I also get 81. So the fallback here is not bad either. And it produces, of course, the same result.